Right now, there are Fortune 500 engineering teams basically begging their CFOs for millions in expanded GPU budgets.
Oh, yeah. Millions and millions.
They're holding up these charts, showing exploding user demand. They point to the global GPU shortage, and they claim that if they don't get more compute immediately, their enterprise AI initiatives are just going to hit a brick wall.
And according to this fascinating stack of operator playbooks, strategic memos, and infrastructure notes we're looking at today, those engineering teams are completely wrong about why they are running out of money.
Completely wrong. The great enterprise AI GPU shortage, it might actually be a massive illusion.
It is an incredible misdiagnosis of the problem. I mean, we are looking at a situation where the visible symptoms, the inexplicably spiking cloud bills, the constantly upward moving GPU quotas.
Right, the things keeping CFOs awake at night.
Exactly. Those symptoms are masking a much deeper architectural failure. So our mission for this deep dive is to unpack this hidden leak. The sources reveal that what most enterprises are suffering from is not a lack of raw compute capacity.
It's something else entirely.
Yeah, it's a massive systemic failure in something called inference routing.
Because, demos are incredibly cheap, right? The ones that
Right.
look so magical in the boardroom, they are totally contained.
Oh, absolutely. Demos are basically free compared to reality.
But production workflows are quietly eating gross margins for breakfast. So whether you are an infrastructure engineer trying to optimize a stack, a founder managing burn rate, or just insanely curious about the actual economics of the tech boom, this deep dive is going to completely change how you view the deployment of AI.
We really need to start by breaking down this choke point illusion.
Let's do it. What exactly is the choke point illusion?
Well, it's the belief that raw compute is the only variable that matters. Leadership teams remember that flawless initial demo, and when they move into high-volume workflows, they just assume the only way to scale is to brute force the infrastructure.
Just buy more servers.
Right. But the sources make a very sharp diagnosis here. They argue that most AI cost problems are not GPU problems. They are routing problems wearing a GPU invoice.
A routing problem wearing a GPU invoice. That is such a vivid way to put it. Let's ground that for a second. Think about a rapidly growing city dealing with massive traffic gridlock.
Okay, classic urban planning nightmare.
Right. So instead of installing a centralized system of smart traffic lights or building bypasses to route commercial trucks away from downtown.
Which would be a routing layer, essentially.
Exactly, a routing layer. Instead of doing that, the city government just decides the solution is to buy everyone bigger, faster cars. They just keep throwing more GPUs at the problem and wondering why the gridlock is getting more expensive.
And what happens when you buy everyone bigger, faster cars in a city with no traffic lights? I mean, the gridlock doesn't disappear. The crashes just become exponentially more expensive.
It's just a faster pileup.
Precisely. You are increasing raw capacity without implementing any control over the flow. The real control point in an enterprise AI system isn't the raw GPU capacity at all. It is the inference routing layer.
The inference routing layer.
Yeah, this is the critical and often totally missing decision point sitting directly between the AI demand coming in from your users and the compute supply going out.
Okay, so if I'm an application, right, and I'm setting a prompt, what are the specific decisions that this routing layer is supposed to be making in real time?
Well, every single AI request should trigger a systematic evaluation, like which specific model should handle this task based on its complexity.
Okay.
In which cloud region should this run to minimize cost? What is the acceptable latency budget? Does the user need this in under 200 milliseconds, or is this a background job that can just take 10 seconds?
Right, because those cost completely different amounts.
Exactly. Plus, what are the privacy or compliance constraints on the data in that prompt? And crucially, if the primary path fails because an API is down, what is the automated fallback path?
But when those decisions aren't made systematically, the system doesn't just crash, right? Engineers still have to ship products.
They do. The show must go on.
So instead of dynamic routing, they fall back on defaults. They just hard code a path. And that brings us to the hidden tax. What do these default choices actually look like inside a code base?
The sources refer to this as an expensive muscle memory. It looks like single cloud environments where every request is routed to one provider simply because that is where the company's legacy data lives.
Just out of habit.
Totally out of habit. It looks like default model loyalty, where every single prompt goes to the most famous flagship AI model on the market. And it looks like locking everything into the highest precision settings available, completely regardless of the task's actual requirements.
Okay, I actually have to push back on that being a failure, though. Because if a company's deploying enterprise-grade AI, shouldn't defaulting to the most advanced, highest precision model be the safest bet?
It definitely feels that way to the developers.
Right. Think about the psychology of the engineering team. Nobody wants to be the developer who broke the new AI feature by routing a customer query to a cheap, underpowered model that hallucinates some offensive answer. Defaulting to the flagship model just sounds like self-preservation.
Oh, the fear of getting fired for a hallucination is incredibly real, and it drives massive infrastructure waste. Engineers are prioritizing safety over margin because they don't have a system that allows them to fail gracefully or measure quality across cheaper options.
So they just buy the most expensive insurance policy every single time.
Exactly. But not every task requires a genius level model. High volume workflows like support summarizations or background data extraction or, basic code autocomplete. Sending those simple repetitive tasks to the absolute most expensive model is like using a supercomputer to calculate a 20% restaurant tip.
The math will be flawless,
Huh.
but the unit economics are totally absurd.
Completely absurd.
Let's invent a scenario to put some hard numbers on that absurdity. Imagine an enterprise running, say, 50,000 customer service chat summaries an hour. It's a basic background task.
Super common use case.
If the developer hard codes that to a premium flagship model, let's say that costs the company $1,000 an hour in API fees. But if a proper routing layer intercepted that simple task and shunted it to a smaller, fine-tuned open source model running locally, that cost might drop to $40 an hour.
Wow.
That is a $960 per hour tax simply because the engineering team was afraid to route dynamically.
And you have to realize that $960 per hour tax compounds silently across dozens of microservices. One team hard codes the flagship model. Another team ships against a single expensive U.S. cloud region just because it was the easiest to get past the compliance officers.
And nobody's looking at the aggregate cost of those safe choices.
Over time, these individual safety-driven choices stack up. The beneficiaries of this obscurity are the hyperscalers profiting from cloud lock-in and the model vendors benefiting from unquestioned loyalty.
And the enterprise just quietly pays the tax. But, that $960 an hour leak is exactly why the conversation is violently shifting right now. Here we are in the middle of Q2 2026, and those hitting costs have finally compounded to the point where they're hitting the boardroom.
It is causing a massive reality check for CFOs everywhere.
So the dynamic in the boardroom has entirely flipped.
Completely flipped. For the last 2 years, the environment was totally driven by FOMO, fear of missing out. And the only question the board asked was, are we deploying AI faster than our competitors?
And now,
Now, the very uncomfortable question CFIs are asking infrastructure leaders is, why did our massive AI investment improve absolutely nothing on our gross margin?
ouch. So if you are that CFO or the infrastructure lead preparing to defend your budget, you really have to know how to spot this routing failure in your quarterly reports. Where does this leak actually show up on paper?
Well, you look for the disconnect between the narrative of your pilots and the math of your production scale. The celebrated AI success stories in most companies are based on heavily curated pilots.
Right, the boardroom demo.
Exactly. They had controlled variables, limited user sets, highly predictable token counts. But then you contrast that with the reality of high-volume production workflows.
Workflows like RAG search and agentic back office tasks. Let's just ground those terms for the listener for a second. RAG, or Retrieval Augmented Generation, is where your AI isn't just answering from its pre-trained memory.
Right. It's doing research.
Yeah, it's constantly digging through your company's proprietary databases like SharePoint, Jira, or Slack, pulling hundreds of pages of context before generating a response. And agentic tasks are where the AI is operating autonomously in the background, executing multi-step processes, checking its own work, and iterating.
And both of those workflows are incredibly token heavy. I mean, every time a RAG system digs into Jira to pull context, it brings thousands of tokens. Every time an agent loops through a background task, it burns tokens.
So the volume is massive.
Huge. Now, in a mature digital infrastructure, as the volume of those tasks scales up, your unit cost per task should compress.
Right, basic economies of scale.
But exactly the opposite is happening in enterprise AI right now. If the volume of your R queries is up 10x, but your cost per query is remaining completely flat at the premium tier, you are bleeding out.
That flat line on the unit cost graph is the mathematical proof that you are missing a routing layer.
It's the smoking gun.
So an engineering lead who walks into that Q2 margin meeting and says, hey, our agentic workflows are super popular. Please authorize another $2 million for a GPU cloud quota. I mean, they are going to get laughed out of the room.
They will be viewed as an absolute liability. The teams retaining credibility right now are the ones proving control over their unit economics. They are the ones showing they can move the exact same workload through a cheaper, faster path without degrading the user experience.
Once the CFO identifies this margin leak, the mandate is obviously handed down to fix it. But the technical friction involved in building that fix is immense.
Right. Oh, it's a huge headache. And this is where we have to look at the operational nightmare of manual scripting. When leadership says optimize costs, the first instinct for a tired engineering team is to just patch the leak with duct tape.
What does that duct tape look like?
They might hire systems integrators to write some custom scripts. They build a rudimentary logic gate, like if prompt is short, send to cheaper model. But the sources strongly warn that this approach stops one layer too early.
Because it doesn't scale.
It creates a fragile, unscalable mess. The routing logic ends up scattered across bespoke glue code in a dozen different repositories. It essentially functions as tribal knowledge.
Oh man, so if the one engineer who wrote the script dealing with API rate limits leaves the company, the whole optimization breaks down.
Exactly. Manual scripting simply doesn't handle the friction of different context windows between models or translate prompt formats on the fly.
It's like a logistics company realizing they're wasting fuel, and instead of implementing software, they just hand out walkie-talkies to a team of dispatchers. The dispatchers manually call drivers to say, hey, there's traffic on Main Street, take the highway.
Right, which works fine for 5 delivery trucks.
Exactly. But when you scale up to 5,000 trucks, the dispatchers are overwhelmed, the radios are useless, and the trucks are just idling in gridlock anyway. You cannot scale walkie-talkies.
You really can't. The alternative to the walkie-talkie approach is what the sources call a dedicated routing layer. They refer to it as an AI BGP.
BGP, Border Gateway Protocol.
Yeah.
For context here, BGP is the underlying protocol of the internet. It is the automated system that decides how packets of data travel from a server in Tokyo to your laptop in New York, instantly finding the most efficient path through thousands of possible networks. So the sources are arguing for an AI network switch built specifically for enterprise prompts.
Yes, a central neutral broker that sits transparently between the application layer and the compute layer. Let's look at how this functions technically, because the mechanism is honestly brilliant.
Okay, break it down for us.
Instead of an engineer hard-coding an OpenAI or Anthropic API key directly into the application simply sends the prompt to the BGP switch.
So the switch intercepts the payload.
Yes. The switch reads the prompt's metadata. It evaluates the size of the payload. It checks the policy tags. Let's say the metadata indicates this request requires sub 200 millisecond latency because it's a real-time user chat, but it doesn't require complex reasoning.
It knows exactly what the prompt needs.
Right. So the switch instantly queries its registry, identifies a smaller, locally hosted Llama model that meets those criteria, translates the prompt to fit that specific model's format, forwards it, and logs the cost. All in milliseconds, completely invisible to the end user.
And it solves the compliance nightmare too, right? If that switch reads a metadata tag indicating the prompt contains GDPR-sensitive data, it automatically knows it cannot route that request to a cheaper US-based server.
Exactly. It enforces policy as code. It requires per-request observability. You know exactly where every prompt went, why it went there, and what it cost.
And that observability is critical because it removes the fear we talked about earlier. If you have comprehensive audit logs, engineers aren't terrified of hallucinations anymore. They can trace exactly which model produced which output.
Exactly. But the most vital component is the developer middleware. This switch has to integrate seamlessly so you don't have to rewrite thousands of legacy applications just to optimize their routing.
Now, I can hear infrastructure leaders listening to this and thinking, well, a dedicated, policy-driven AI network switch with real-time payload translation sounds like a 6-month, $5 million consulting nightmare. I mean, I'm never getting budget approval for that.
And that assumption is the biggest barrier to solving the problem. But the sources attack it directly. You do not need a bloated 6-month strategy to prove this leak exists or to get the buy-in to fix it.
Really? How fast can you do it?
You can prove it with your own company's data in 48 hours.
The 48-hour asymmetric bet. How does a team actually execute this without disrupting production?
It requires an offensively practical test. Day one is pure execution. You isolate 3 production-like workloads. Not toy prompts engineered to look good, but real, high-volume workloads your company relies on right now.
Like the support summarization, the RV search, the code generation.
Exactly. You take those 3 workloads, and you manually run a massive sample set across at least 2 different tier levels of models and 2 different cloud regions. And you measure the reality of 3 metrics: unit cost, latency, and quality.
Think about the suspense of doing this. If you pull 1,000 of your company's RV ag queries right now and route them to a model that costs a tenth of your default, what happens to the quality? Does it drop by 50% or does it drop by 0?
The data is usually a total shock to the system. The sources indicate that when teams run this 24-hour test, they consistently find a cost spread of 40% or more for the exact same quality of output.
A 40% difference in cost for the exact same quality just by changing the route.
Then the realization hits them hard. They have a 40% spread available, but they have absolutely no automated mechanism in their architecture to exploit it. That is the moment the margin leak stops being a theoretical concept and becomes a measurable reality sitting in their own production environment.
So you spend day one gathering the math, but math alone doesn't change enterprise behavior without leverage. How do you take those metrics to a CFO on day 2 without sounding like you are pitching an expensive science project?
Well, day 2 is about securing the mandate. You synthesize that data into a one-page document, call it the AI unit economics gap. You show the CFO the current default path and its cost. You show the optimized path you discovered. And you point to the missing routing layer that is currently preventing the company from capturing that 40% savings.
And you don't ask for $5 million to build the BGP switch across the whole company?
No, not at all. You ask for a highly focused 60-day inference routing pilot on just one of those specific workloads. It is an undeniable proposition. You are telling leadership, hey, I found a 40% margin leak in this one specific pipe. Give me 60 days to build a dynamic valve for it.
And if you can demonstrate genuine savings on that one workload without quality loss in 60 days, you fundamentally change your department's relationship with the board.
Exactly. You stop negotiating from a position of weakness, constantly asking for more GPUs, and you prove operational control.
And once you prove control on a single high-volume RAG or agentic workflow, the mandate to expand that routing layer horizontally across the entire enterprise just becomes obvious.
It does. The synthesis of all these memos and playbooks points to a singular reality. Raw compute capacity is rapidly becoming a commodity. The next massive competitive advantage in enterprise AI will not belong to the company that strokes the biggest check to a hyperscaler for the largest GPU pool.
It's not about whoever has the most hardware.
Not at all. The advantage belongs exclusively to the company that controls the decision layer between demand and compute.
You have to move away from expensive muscle memory and hard-coded defaults. You have to treat inference routing as a first-class function of your infrastructure. You have to own the choke point.
Right. And let's take that concept to its logical and highly provocative conclusion.
Let's hear it.
If inference routing truly becomes the ultimate control point in enterprise AI architecture, it threatens to upend the entire power dynamic of the tech industry. Right now, the massive AI model vendors hold all the leverage. They train the flagship models, and enterprises pay a premium for access.
Maybe the enterprise feels locked in to the intelligence of that specific vendor.
Exactly. But if an enterprise successfully deploys a perfect AI BGP switch, a layer that instantly, invisibly evaluates a prompt and routes it to whatever model anywhere in the world offers the best cost to latency ratio at that precise millisecond, what happens to the model vendors?
Wow.
Do the companies who master routing eventually commoditize the AI models entirely?
They absolutely would. I mean, if the routing switch is smart enough to guarantee the SLA and the quality, the enterprise stops caring whether the response was generated by Model A, Model B, or some localized open source alternative. The intelligence itself just becomes a raw material.
It could turn today's towering AI giants into interchangeable, invisible utilities. In the same way you don't care which specific power plant generated the electricity lighting your office, as long as the lights turn on, enterprises might stop caring whose logo is on the AI model analyzing their data.
That is profound. The true power in the future of AI isn't the intelligence itself, it is the logistics of deploying it.
The logistics are everything.
That is a staggering implication. The intelligence is the commodity, but the routing is the moat. So I want you to look at your own tech stack right now. Who is actually making the routing decisions for your workflows today? Is it a deliberate, systematic policy acting as code?
Or are you just paying a massive hourly tax for the comfort of hard-coded defaults?
Because if your strategy is just throwing bigger cars at a broken traffic grid, the bleeding on your gross margins isn't going to fix itself. It is time to stop blaming the GPU shortage and start measuring the route. Thanks for joining us on this deep dive.